In our previous video, we featured an animation of a fighter jet equipped with an air-to-air missile and an infrared IR sensor. This missile allows the jet to target enemy aircraft using heat signatures. If you haven't seen it yet, be sure to check it out. Welcome to Animated Orbit, where we break down complex aviation concepts in an easy-to-understand way. In today's video, we'll explore some key elements of aircraft design, including the buttock line, waterline, fuselage station line, chord line, mean aerodynamic chord, Mach, and dihedral angle. Let's dive in. Cockpit. This is where the pilots operate the airplane. It contains controls, navigation systems, and instruments that display flight information. Fuselage Body. This is the main body of the airplane. It houses the cockpit, passenger cabin, cargo, and sometimes fuel tanks. It also serves as the base to which other parts like the wings and tail are attached. Engines. The engines generate thrust, which moves the airplane forward. They can be jet engines or propeller engines. The forward motion enables the wings to generate lift. Wings are crucial for lift, which allows the airplane to fly. They are shaped to create a pressure difference between the top and bottom surfaces. Flaps and slats on the wings help control lift during takeoff and landing. Ailerons found on the trailing edges of the wings, these control the airplane's roll. Ailerons move in opposite directions to tilt the wings. Tail section, empennage. This provides stability and control to the airplane. Vertical stabilizer controls yaw and prevents the airplane from swaying side to side. Airplane's altitude. Rudder. The rudder controls the airplane's yaw, side-to-side movement. It is located on the vertical stabilizer and moves left or right to turn the airplane. Elevator. The elevator controls the pitch, up or down movement of the nose. It is attached to the horizontal stabilizer and moves to adjust the airplane's altitude. Major zones in aircraft. In aircraft design and maintenance, the structure is divided into major zones to simplify inspection, maintenance, and documentation. Purpose of major zones. Organization. Dividing the aircraft into zones helps in systematic planning and execution of maintenance tasks. Standardization. It allows manufacturers and maintenance teams to follow universal practices. Efficiency. Zones make it easier to identify, locate, and work on specific components or systems during inspections and repairs. Examples of major zones: Zone 100, fuselage nose, including the cockpit. Zone 200, main fuselage section, including passenger and cargo areas. Zone 300, tail section, empennage. Zone 400, left wing. Zone 500, right wing. Zone 600, landing gear and associated structures. Zone 700, engines and nacelles. These zones ensure that maintenance and inspections are thorough, organized, and aligned with safety standards. Fuselage Station, FS. Definition: a reference point system used to measure locations along the length of an aircraft's fuselage. Units, usually measured in inches or centimeters from a fixed reference point, commonly the aircraft's nose or a designated zero station. Purpose: it helps engineers and maintenance crews pinpoint exact locations for components, inspections, or repairs. How it works: the fuselage is divided into sections or stations along its length. Each station is marked with a number that increases as you move backward from the nose. Example: FS0 is at the nose, FS200 might be a point 200 inches behind the nose. Practical use. Design helps position components like seats, fuel tanks, and cargo. Maintenance simplifies identifying and communicating specific locations on the aircraft. The mean aerodynamic chord, MAC, is the average chord length of a wing, representing its aerodynamic behavior. Chord line, a straight line from the wing's leading edge to the trailing edge. For tapered or swept wings, chord length varies, so Mach is calculated as a weighted average. It helps determine the aerodynamic center, which is crucial for stability and design in aircraft. In simple terms, Mach simplifies complex wing shapes into one representative chord for analysis. Waterline, WL. Definition: This is a horizontal reference line used to measure the vertical position of points on the aircraft. Function: the waterline helps in determining the height of different components relative to a base reference point, typically the underside of the fuselage. Example: WL100 indicates a point 100 inches above the base waterline. These reference lines are essential in aircraft design, maintenance, and inspection, ensuring precise measurements and alignment of parts. Buttock line, BL. Definition: this is a vertical reference line used to measure the lateral, side-to-side position of points on the aircraft. Function: the buttock line helps in determining the distance of components from the aircraft's central axis. Example: BL20L indicates a point 20 inches to the left of the center line, while BL20R refers to 20 inches to the right. Wingspan: the wingspan is the total distance from one wingtip to the other. It determines how much air the wings interact with, affecting lift and efficiency. Example: gliders have long wingspans for high efficiency, while fighter jets have shorter spans for agility. Dihedral angle: the dihedral angle is the upward tilt of the wings from the horizontal plane. It improves stability by automatically correcting the aircraft if it tilts to one side. Example: seen in commercial airliners for better stability during flight. Anhedral angle: the anhedral angle is the downward tilt of the wings from the horizontal plane. It reduces stability but improves maneuverability, often used in military jets. Example: fighter jets with anhedral angles are more agile in combat situations.